Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Dwight. Looks like you have a head problem. Today, folks, we are going to have no problems because we're going to be learning about something called oscillating motion, like Dwight. His head oscillates. Let's go.
Houston, we don't have a problem. Today we're starting something fresh and new. Something new. We've been talking about kinetics, how things move for just a long, long time. And now what we want to do is we want to switch to sort of another like big topic in Physikland. And it's how waves work. Like, yeah, like that kind of wave. But there's lots of kinds of waves. And the introductory video is to talk about this topic. Oscillating motion. Now you've seen oscillating motion. Check it out.
Hey, Dwight. Looks like you have a head problem.
From The Office, oscillating motion, back and forth and back and forth. So if you've got something that oscillates, you'll discover that waves oscillate. They have some ways we can describe how fast and how long and how wide and deep or whatever things oscillate. So let's talk about the big time that the big things that we talk about, P-E-R-I-O, period. The period of motion is the time to get through one cycle. How long does it take for the head to bob back and forth, right? A lot of things, they have a period. And the second is called this. It's the number of cycles in 1 second. So let's talk about this. This is called the period. That's a T. This is measured in seconds. And this, if you think about it, it's cycles per second. It's like the inverse. Usually we just say this is equal to seconds to the -1 because the seconds are in the bottom corner. And we measure things in something called an Hz, a Hertz, after some famous physicist dude, Mr. Hertz. So time and period is how much time it takes to go through one cycle, and frequency is the number of cycles that happen in a second. It could be like a half a cycle per second or whatever. It could be 15,000 cycles a second. A lot depends on the type of oscillating motion we're talking about. And again, we're headed towards discussing waves, and some waves travel crazy fast, etc., so they're going to oscillate at different speeds. So these are the two big things that we're going to measure. And the third one is the amplitude. Now, we're kind of getting a bit into the whole wave motion. This is typically how energetic slash, it's also more than that, really. When we talk about waves, it's the displacement. This is typically measured in meters. So later on we'll talk about how this all works. But these are the three big things that we're going to measure, focusing mainly on number 1 and 2 early on, and this will become a bigger deal later on as we go through these videos. So one thing we can measure in an oscillating motion is this example right here, right? We've got the climber climbing uphill, and we measure your heartbeat. It's 82 beats per minute, right? And we've got two questions. What's the frequency in hertz? Now this is beats per minute. Remember, hertz is in seconds to the -1. So if you think about it, it's 82 beats. Watch how I do this, per 1 minute. I want it just in seconds to the -1. So I'm really just going to convert minutes to seconds. And I'll say 1 minute is 60 seconds. We take 82, divide by 60, and we get 1.4. We could say seconds to the -1, or 1.4 hertz. Make sense? Now the question that would next be asked, as you can see, right? What's the period? Now the period, we didn't write this earlier, definitely write this down. The period is equal to 1 over the frequency, right? So I'm just going to take 1, or actually so I'm going to take 1 divided by 1.4. And you get 0.71 seconds, which means that you have one heartbeat. If your heartbeat is your heart is beating 82 beats per minute every 0.71 seconds beat. So folks, simple, right? We're just learning about how things oscillate. It could be, or it could be lots of things. And we're going to learn about the different things that can oscillate, oscillation motion simplified. Hey, Houston, we have no problems. We'll see you in class.